So when we divide polynomials, the easiest case is when the denominator is just a monomial. So here we go. What you do when the denominator, what you're dividing by, is a monomial, and we'll talk about it in class. You'll see in the book there are a variety of ways of writing these types of problems, and we'll go over it. But this is clearly a division problem. It's a fraction. How do you divide these polynomials? Well, if it's a monomial, what you can do is you can think of it as basically three simpler problems. Because what's up is the 4x cubed y is dividing all three things on top. And I would never actually really write all of this out, but I think for your benefit I will do that here. Okay, if I was just doing this problem on my own, for fun, I guess, I don't know. I wouldn't write it all out. The idea is that the denominator divides all three parts in the numerator, all three terms. So we have a 20 x to the 5th y squared, 12 x cubed y cubed y cubed. I'll fix that 3 in a second. And then there we go. Okay. So it's dividing all three parts. And I would just think of that in my head, and if that's what's going on. 3. There, it's a little better. Anyway, all right. And so then you do all three of these problems individually. All right. So it is 20 divided by 4 is 5. X to the 5th divided by x cubed is x squared. Y cubed divided by y is y to the 1st. Okay, plus, and then we just keep on trucking. It's 3. The x cubes totally cancel in the middle term, or middle part of the problem, so don't worry about it. And then we have y squared, and then over here we have plus, well, 1/2. All right, don't freak out that this is a fraction. 2 over 4 reduces to 1/2. No big deal. X, y to the 4th, and then that's it. There are no like terms combined, so we are done. If there, were going to be some like terms combined, we would have noticed that actually at the beginning of the problem, because they would have been like terms in the first place. All right, so there we go. So that's if it's a monomial. Now it's much, much, much harder if it's not, and so most of the video will be if it is a binomial. All right. So what this is actually called is called long division of polynomials. Alright, we have to do long division of polynomials, and what I'm going to do as a little side example is remind you how you do long division of numbers. And when we write this out, what's going to happen is that they kind of mirror each other. Alright, there's a lot of similarities in what you do here. So I'm going to remind you of how you do long division of numbers. Alright, and actually maybe I'll go like back and forth between the two problems and do them simultaneously. That might be the way to go. So this is really actually, let me actually make it clear that this is an example of what is called long division. Oh my gosh, I can't type. Wow, I really can't type. Alright. Okay. Wow. That's what this is often referred to. So if you need, look that up on YouTube if you want more on this. All right, more than this one example I'm about to do. So remember how you do long division of a number. So we write like this. So we go 12, and then the 167. All right. Do the same thing over here. I write it out. It's very similar notation-wise. I do x plus 3. I do the bottom, the denominator goes outside the little box, and I go 3x squared plus 4x plus 2. Alright? Okay, and over here we see how many times does 12 go into 16? Well, in this case it's once. Okay? We do a similar thing over here. Notice we only look at the beginning of what's inside. We don't look at the 16, right? We don't look at the whole thing. Similar thing here. We only look at what are called the leading terms. Leading terms are the ones with the biggest exponents. That's a term I don't think I talked about earlier. The leading term is the one with the biggest exponents. So leading term, leading term. And we got to go, all right, what do we do? What do we multiply this by to get to the 3x squared? Well, this is 1x So 1 times 3 gives us the 3. Okay, we put it directly above. And then x times x gives us x squared, so it's a 3x. Okay. In class, when we have a little bit more time, I might show you how to like show your work here. You know, if you have trouble figuring that out, then I'll show you something that should help that. But right now, I'll just give that to you. 1x times 3x equals 3x squared. Okay. Then let's go back over here. 1 times 12 gives us 12, and we subtract. Okay, and then, you know, keep on trucking in a minute. We do the same exact thing here. Over here we did 1 times 12. Here we do 3x times the x plus 3. So you might have been thinking, like, oh goodness, what do we do with plus 3? Well, here's where the plus 3 comes in. 3x times x plus 3. 3x times x is the 3x squared. 3x times 3 is a 9x. Oof. Okay, and we subtract. I have trouble drawing horizontal lines sometimes. Boom, that's better. We subtract. I'll put parentheses around that, maybe. And then the thing to remember is, when we subtract, we are subtracting these polynomials. Alright, so we subtract polynomials just like we did before. 3x squared minus 3x squared. Notice these are like terms are lined up. It's perfect. 3x squared minus 3x squared is, well, 0. So I'll draw the 0. I don't really ever need to. I just want to emphasize that we subtracted them and they canceled. That should always happen. And we 4x minus 9x. We are subtracting everything. In fact, it might even be a good idea to do this to remind yourself that you are subtracting everything down here. Alright? Just like you subtract 1 and 2 here, you subtract the whole 12, you're subtracting both terms. So it's negative 5x. Okay? Drop down the 7 up here. Drop down the plus 2. Okay? See how these are like mirror images of each other. It's the same process, only instead of arithmetic up here, it's algebra down here. Alright? Structurally, they are kind of identical. You know, pretty darn close at least. So then what do? Well then, notice how you really kind of, when you do long division, you ignore what's up here now, you're worried about what's down here. And you want to know how many times is 12 going to 47. Okay? Same thing here. How many times is this guy going to this guy? You're ignoring the rest up here. So it's 12 goes into 47, almost 4 times, 3 times. So 3, and 3 times 12 is 36. Okay? How many times does this go into this? So that's a harder problem. You basically handle the same way we did the first one. You only look at the leading terms. So how many times does x, 1x, go into negative 5x? What do you have to multiply this by to get to this? Well, it's negative 5. Okay? If you do 1x into 5x, it goes negative 5 times. To do this times, or excuse me, to go from here to here, you got to think, what do you have to multiply by to get there? And it's a negative 5. Alright? And so you multiply negative 5 times the 1x plus 3, and you get negative 5x minus 15. Okay? And you're going to subtract both of these. Alright? We'll subtract here, we get 11. So to finish it off, this is 13 with a remainder of 11. Alright? Notice we stop as soon as the remainder is smaller than the original divisor. This is called the divisor. Same vocabulary here. The x plus 3 is the divisor. Okay, we stop as soon as we hit that. Actually, let's do that over here. We subtract, and we get, well, this is 0. Okay, I'm not going to write it this time. There's really no reason to write it. In fact, maybe I should erase that because it's kind of silly. Okay, always cancel. It might be better, actually, maybe like kind of, boom, these cancel. Boom, these should always cancel, that leading term. Okay, and we do 2 minus negative 15, so it's 2 plus 15, so it's 17. So the remainder is 17, alright? But that's not really how we write the answer. And sometimes, I don't know, in elementary school, I don't know how you guys learn to write these answers necessarily all the time. So what really this is saying is this is telling us, over here in the regular long division, it's telling us that 167 divided by 12 is equivalent to The quotient, the 13, the quotient is 13, right? That's that old vocabulary there. And the remainder tells us that what's left over is 11 twelfths. 13 and 11 twelfths. You maybe you might see this as a mixed fraction. But whatever, it's 13 plus the remainder. Okay, so it's quotient plus remainder over the original divisor. 13 and 11 twelfths is equivalent to this fraction here, this improper fraction. Guess what? Same deal down here. Let me bring this down. This fraction, this rational expression, is what we call this, and we'll talk a lot more about these rational expressions later in the semester. It's equivalent to 3x minus 5, the quotient, minus 5, plus the remainder over the original divisor, which was the x plus 3. These are the same thing, that these are equivalent to each other. Okay, so that's how you do long division of polynomials. Alright, there you go. We'll probably have to do some more examples in class because this is a pretty tough one, but hopefully that's a good start.